So let's start with the session. I think not everyone has joined, but yeah, keeping the time in mind, we can continue. This session is about understanding AWS Redshift and why someone needs to learn AWS Redshift and what it can offer in terms of job opportunities and the market share it has, and the ecosystem it belongs to the larger services provided by AWS. So considering that, let's discuss everything in detail. So first, why someone needs to learn AWS Redshift? Okay, so since some of you are from non-technical background and some of you are from technical background, you may have some understanding or have learned or have an understanding on what a database is or what a data warehouse is. So Redshift is one of the data warehouses provided by Amazon Web Services. And so first of all, AWS as a service or as a cloud provider is one of the leading providers when compared to Microsoft Azure or we have Google Cloud, and there are some other providers also like Oracle. They also provide database services, and we do have many other services, but these are the primary players or the market leaders, I can say. So AWS has more than 35% of the cloud share, so that's a very significant share in the market. So learning AWS Redshift will definitely be helpful because it's like if you have 100 companies who are based on cloud, and you have 35 companies using AWS platform or AWS as a cloud services. So you almost have like 35% of opportunities in that aspect. So Amazon is a uh, leader, or it has dominance in data warehousing market share. So other um, market leaders when compared to Amazon Redshift are we have Snowflake, we have Google BigQuery, and we have one of the services provided by IBM and also Teradata. But yeah, when compared to everyone, Redshift has its own market share and it has its own large company partnership. Like there are a lot of Fortune 500 companies or other software companies. They do rely on AWS Redshift as a, I mean, they do utilize AWS Redshift as a data warehousing service. And coming to the next point, we have multiple career opportunities in cloud data warehousing. So these days, you may be aware like every company would want to move away from on-premises, but it totally depends on the company. They will do analysis, and based on their requirements and the capacity they have on premises, some companies prefer to migrate their services to or their platform to cloud. It could be AWS, Microsoft, or Google. It could be anything. But yeah, these days we see this trend of migration because it has any cloud, especially if we talk about AWS, it has a lot of services that integrate with each other in terms of application development or database management or sending notifications, um, and we can say the services that are dependent on machine learning, deep learning. So all these services are integrated in AWS. So considering that many companies are trying to migrate their infrastructure to cloud, and in that aspect we see tremendous growth or career opportunities in the cloud data warehousing. And if you follow some news regarding the company's investment, so AWS has invested more than 1 billion or $3 billion in India. So they are setting up a lot of data centers, a lot of data warehouses. to cater to the growing market demand. So keeping that in mind, we can directly correlate it to that. We will have a lot of career opportunities in the coming years. And the next very important point is integration with the AWS ecosystem. So, like I've said, so there are more than 100 different kind of services provided by AWS within database management or data tools. There are more than 10 services for different use cases. Some are services developed for real-time data processing. Some services developed for capturing or analyzing historical data, and some for data transfer. So for different use cases, considering the cost as a parameter and the retrieval time as a parameter, we have numerous kinds of services within AWS which integrate easily with each other. So that provides us a great edge in adopting or in learning AWS Redshift as a service. And then the last and important point is community support and resources. So these days we have a lot of people who are associated with AWS or Redshift as a service. A lot of companies who are working on Redshift or using Redshift as their data warehouse platform. Uh, so there is a good community where whenever some user or an engineer runs into some problem, there is always someone ready to help and solve the problem, or someone may have already faced it and may have already provided a solution to that on various online blogs or other help platforms. So considering all these, so it is very good to learn AWS Redshift, and it can act as a starting point in um, launching your career as a database administrator or a database engineer for Redshift. I'll take a minute here. Do you have any questions before I move to next slide?
Nothing from my side.
No, I don't have any.
Okay.
I have one question. So when we mention as the data warehousing as the Redshift,
Mhm.
so do we need to create all the tables as the dimension and fact?
Yeah, that's part of a DB or a data engineer job. I'll come to that point. Yeah, but yes. So some companies, so they already have that data infrastructure already set up. They do have those fact tables and dimension tables already created, and based on the requirement or the on the launch of new projects, there may be a requirement to create new tables. It could be fact or dimension, but yeah, it totally depends on the requirement. But yeah, as a DB engineer or a Redshift engineer, we should be able to know how we can create a table, database, or a schema.
Okay. The reason, the why I have asked the question, when I went through few of the online tutorials,
Mm-hmm.
so they are directly dumping the data into the standard table. So I don't see they creating. I mean, what are the demos I have seen in the YouTube?
Mm-hmm.
They was not created based upon the data warehousing standard. So I was very curious to know, even without data warehousing standards, also just normal file which we can load into one table and utilize in the Redshift. I mean, generally, what would be the ideal way? So,
So, so usually when we are doing some testing or learning online, so the data we work with or that we test is very minimal when compared to the real data where companies like Amazon, Microsoft, or Google, they process huge amounts of data. So when we are working with large volumes of data, then it is very important for us to make that segregation between a fact table and a dimension table, and that's the
okay,
best practice to create tables. But
okay,
yeah, usually in real time scenario, usually data engineers create in that fashion. Okay, thank you. Moving on to the next slide. So who can learn AWS Redshift? So basically, not just with AWS Redshift. If for any skill or anything, if someone wants to learn something, they can just go for it, provided they understand what the career opportunities are, how the market is going to be, how the compensation is going to be. Considering everything, yeah, someone can learn any skill. But coming to AWS Redshift, as I have said in the previous slide, it has a lot of opportunities, and a lot of companies they do use AWS Redshift. So it only gives us importance in learning, so that it already has the market share, it already has the job opportunities, and even the compensation is relatively much better when compared to other skills. And uh, these days, roles related to data, it could be a data analyst or a data engineer or a BI engineer, they do have a significant importance on how they are going to help for the growth of the organization. So anything related to data these days have a significant importance, and we can just go for that. And this will be mainly so if someone is already into some roles like database developer or administrator or a data engineer or a BI engineer or a data analyst, all the roles related to data, it will be helpful for them if their organization is already using Redshift. And learning this will only add or just help them upskill from where they are now. So anyone can learn it, but it will really help data people to move to take their career to next level. Yeah, now we know. So in the previous two slides we have learned, like we have discussed why we should learn Redshift and who can learn Redshift. So provided that you have decided to learn Redshift, so when you get a job, or let's say there's already a DB or or data engineer who is already working on a Redshift, so what would be their day-to-day uh, actions, or what kind of role they play in managing their clusters or Redshift cluster, if I have to mention. So the very and the obvious step is, so you should know how to install and configure a Redshift cluster. So you need to have a basic understanding of that. And once you are able to launch your own cluster with the defined number of nodes and the node type and other configuration, um, so once you create and set up your Redshift cluster, you need to you need to be able to move data into that cluster, right? And we cannot just simply move data into any database or any cluster without creating or configuring databases, tables, and their schemas. So this is a very important step. And so basically, in a real world scenario, you do create these different kinds of databases or tables or schemas based on the business requirement. So you will basically discuss with your product managers, with your software engineers or business analysts, other people, and for us to report these numbers or the data to the final platform, we need to understand what is the final output they would want. So accordingly we design databases, tables, or schemas. So it's not just a one man's job, it happens after discussions with all the stakeholders involved. And like one of you was mentioning earlier, so this is where designing the fact tables and dimension tables and the other kind of tables comes into picture. So once you're able to create those tables, so you're just creating an empty table and you're not dumping any data into it. And since you'll be working on a production level data, so you cannot just dump the data with some commands, because the data that is produced is large. It ranges from few GB to a few TB. So that cannot be hard coded. So we need to configure it, or we have scripts running to load the data. So after creating the tables, the very next step is to fill those tables with some data. So next, the loading and unloading part comes. So loading the data is moving the data from one source to, it could be anything, to the Redshift. So the source can be like we have discussed earlier. In Amazon we have multiple services that handle data or that store data. So some of the examples are S3. I'm not sure if everyone has heard about it. S3 is stands for simple storage service. It's a object based storage service provided by uh, Amazon or AWS, and it's very cost efficient way of storing the data. And we also have other data services like MongoDB, we have Aurora, and we have Kinesis, Firehose, things like that. So production data comes from different sources, and we should be able to know how to load that data into our Redshift cluster. And once we have, let's say we have loaded the data into Redshift cluster, and what is the objective of having data in a database? Can someone answer that or provide some insights on what you know? Why we need to store the data in a database? What are the use cases?
For Power BI reports, for analytics purpose, they are going to store the data, past data.
Ye- Yeah, yeah, that's right. That's exactly right. Yeah. So all these organizations or businesses, they store the data to mainly analyze their customer behavior, their customer purchasing patterns, on how to understand the customer experience, how satisfied are the customers with the services provided by them. And so what they do is they store the data, and uh, like some program managers, product managers, or business analysts, data analysts, what's their job? They query the data from the Redshift cluster, they try to analyze the past trends and provide those insights to the senior leaders so that they can take some action on the data and what would be the right thing to do to the customer. That is the very primary objective of why we store the data. It's to understand the business and to improve the business, understanding the data. And sometimes it also helps in planning for the future. So if there is an e-commerce website or a company, uh, so let's say in the past year in 2023 they have month on month sales of, let's say, 1 million products or 1 million units. So based on that, they will, using some algorithms, they predict how the sales are going to be for the next year or for next 2 to 3 years. So for them to do that, they need to have historical data for past 1 to 3 years, based on how they want to design that prediction. So for these use cases, it's extremely important for all the organizations to store the data and to analyze it. They need to be able to analyze it. So that's the primary objective. And the next very important step is performance tuning and optimization. So uh, you have created a Redshift cluster and you have created tables and loaded the data. But if you are not able to manage the resources efficiently, it is just going to create a lot of problems for you in the real time. So when the size of the cluster keeps on increasing with the daily incremental data, so every day uh, these backend databases run and they load the data into the cluster. So every day it adds new set of data, so the size becomes large day on day. So you should be able to manage the data. And when someone wants to query that data, there should be an efficient way. It cannot just scan all the records. Let's say if there are 5 years of data, and if your query is running or scanning all the 5 years of records, then it's not a better or efficient utilization of the resources you have. So what the downside of not able to tune or optimize your cluster is, it will just add a lot of cost to your overall expenses, and the bill that comes at a production level, that will be in thousands of dollars. So most of the companies would want to avoid it. and efficient performance tuning and optimization techniques. They help in the efficient storage of the data and also the efficient retrieval of the data to run queries against the cluster. And next, we have monitoring and alerting. So you have the cluster, like I have just discussed. If the cluster runs into some issues, like the disk size is more than 80% or 90%, or the CPU usage is more than 80%. So these are not the ideal cases. So this will only impact your cluster performance, and the reports or the analysis that is dependent on uh, this cluster, all those would be impacted, and it will just create a chaos in the organization. So we want to avoid that. So for us to efficiently monitor, and whenever these use cases which we want to avoid, so we need to create an alert. So it the alert when these criteria are met, considering CPU or disk usage, over usage, alerts are sent to the respective stakeholders like data engineers or database administrators, so that they can take some action like procuring more clusters or optimizing the cluster by removing unnecessary queries or long running queries. So this will really help in avoiding unnecessary situations which will cause a lot of trouble in real world scenarios. And next is backup and recovery. So let's say for some reason, one of the everyone, no, I think, yeah, I'll cover that next. But cluster, when we say cluster, it is a group of computing devices. So not everything, so when we say database, not every all the data is saved into a single disk or a single database. So it's based on the configuration we are setting at the time of launching a cluster. So it is distributed across different nodes. For some of you, this may be new. I'll cover it next. But yeah, just understand that data is distributed across different nodes. And whenever one or all of these databases fail for some reason, you need to have a backup of the data, whatever has been stored till that point of time. When you relaunch the cluster, you need to have access to that previous data. So that's where the backup and recovery feature comes into place, where we take snapshots of the data and do some incremental snapshots for usages at the time of during some unwanted incidents. But yeah, at the end of the day, a DBA need to ensure that data is available even in the worst case scenario. And the next part is the security management. And there are two parts to this security management. One is access management, like who can all query your cluster. So even if you're a DBA administrator, there are people like analyst or product managers who would want to query the data. So they need access to the cluster. So access is one thing, and security management is like uh, saving the cluster from unforeseen incidents like hacking and things like that. For that, we have some configurations that we need to set up, like launching the cluster in a VPC environment or adding additional security with security groups. We will discuss all these things in detail, but just know that security management, both with respect to access management and risk management, these are very important parts of our database engineer. So all these steps, we should be able to do that, and that's what we'll be learning in this session. And it may feel little overwhelming when you are not used to some of these concepts. But yeah, as we learn the topics one by one on a day-to-day basis, everything becomes very clear. And believe me, this is not very tough. It's, I mean, there is good amount to learn, but it's not that tough. Everyone can will be able to learn. Yeah, before I move, any questions here?
Will you explain workload management as well?
Yeah, yeah, yeah.
WLM.
Yeah, yeah. That comes in performance tuning and optimization. Yeah. As part of
Okay.
that, we will discuss workload
And,
management in
and data share is
yeah, data sharing also. Yeah.
okay. Okay, fine.
And next, coming to the agenda of the course. So, at a high level, this is what we'll be learning. But if we have to go little in depth on what we will be learning at a topic level, so I think we'll be discussing all these points, each and every, without missing any. And yeah, very uh, important and the obvious understanding would be the introduction to data warehousing. So in the earlier, like maybe 10 years back, uh, it's not very ambiguous. It's very clear when we say a data or a database. There is a single thing or a single environment for that. But in the modern world scenario where we have big data and where we have different kinds of data, both text data, video data, and the tabular data. So the since the evaluation of the data across different parameters, so there is also need for us to store the data as per their specifications. Like you cannot store uh, data with a video or audio on a tabular database or a relational database. So there needs to be a separate mechanism on how we can store and retrieve that data, right? So as part of that, we have different concepts like data warehouse, database, and data lakes, and there are few other terms also. But yeah, these are the primarily used here. So we'll understand what a data warehousing is and what would be the difference between database, data lake, and so on. And so the previous step which I have mentioned, like the first thing as a database engineer or a database administrator, what you need to do is install and configure your Redshift cluster. So that will what we'll be doing next. So we'll create an AWS account, and IAM role is one of the important services uh, in AWS. IAM role is one of the attributes in IAM. So we have IAM groups, IAM policies, different things like that. So these help in providing access, defining some restrictions in terms of policies. But yeah, we don't need to go in depth about IAM, but just know that it is used for access management from service to service. Or if a individual user, someone like you or me, who wants to log into AWS account and access Redshift cluster, we can create a IAM user and give them certain permissions on what they can do. So in that aspect, IAM is used. And after creating account, we will launch a cluster. We launch Redshift cluster. We'll see on how we can do that. And let's say once we have the uh, cluster ready and we have loaded the data into it, so we need to have a way to query or retrieve that data, right? So for that, we'll be using one of the SQL clients, or we can call it as the SQL workbench also. So we need to install and access it using these workbenches. And Redshift data can be accessed both from the console, which so in the Redshift console, you directly have an some option or a feature called query editor. So there itself you can directly write your queries. You can connect your database and directly write your queries and see the results. If not, we can also install any SQL workbench using endpoints, JDBC, ODBC drivers, and query the data even using SQL clients. So after that, we can connect to the that sample cluster we create and run some queries on top of that. And next, very important concept is understanding the Redshift architecture. So next, as part of Redshift architecture, we have clusters. A cluster is nothing but a group of nodes and node is also nothing but a computing device. So if I have to say the laptop we have, it we can call it as a node. It's an individual um, computing system, right? So we can call it as a node. So even in a virtual or a cloud perspective, a node is nothing but a some computing device which can store the data, which has its own CPU, which has its own disk space, RAM, network bandwidth, things like that, so that it can function independently on its own. Yeah, that's a node, and cluster is a group of nodes. And in a cluster, since we will have multiple nodes, there should be some way that one node should be able to manage all other nodes, so that the processing is smooth and efficient, and there is clarity in what is happening. So that is the main role of leader node. So it connects with it connects with its applications, and acts as a managing system between applications or the API clients and the data processing in Redshift cluster. And we have node slices. Node slices is, and in simple terms, we can say it's a subsection of a node. So in a node, we have some disk space, right? And that space can be logically divided into different sections, and that sections we call as slices. And we have a concept called zone maps. I will not discuss it now because it may be overwhelming, but yeah, when we discuss the Redshift cluster in the sessions, we can go through everything in detail. So for you to understand, I have just shared a representation of Redshift architecture. So here you can see, right? So data API, this is nothing but we can say our production service or different AWS services from where we get the data into the Redshift cluster. And JDBC ODBC is how we can connect to the cluster and retrieve the or analyze the results. So and within AWS or in Redshift is provided as a serverless or a provisioned service. Can someone tell me the difference if you are already aware of? Anything is fine. There are no wrong answers. Just let me know if you already know this concept.
I mean, provisional cluster means we can configure how many nodes and how much compute power we need, and we have a DC2, DS2, and if it is Redshift managed cluster means there won't be any compute. I mean, we cannot select the how much compute power, how much memory we need, like that. That is the difference.
Yeah, absolutely. That's absolutely right. Yeah, thank you. Yeah, that's the main difference. And why AWS provides Redshift in these two as two different services? It totally depends on a certain company. Like, let's say I'm starting a company, and I don't know how my workload is going to be, how my data is going to grow. So if we take a real-time example of Paytm back in the Corona times, so its business has suddenly boomed, right? So when we have limited set of clusters, and when business is growing like anything, then it may not cater or scale to the requirement, and it will fail the all infrastructure. So in those cases, when you cannot predict how your business is going to be, or when you are just starting out, just to see how the market works, so then you need to, or usually companies prefers serverless. And just like you have mentioned, there we don't configure any node type, or we don't configure any capacity, anything like that. So we just configure what is the minimum capacity we need, and to save cost, sometimes we need to define maximum capacity also. So when I say capacity, it's the number of nodes or number of computing devices. So what Redshift does is based on your workload. So let's say you start a e-commerce company. On day one, there are 100 customers, but on day two, suddenly there are 10,000 customers. So your Redshift based on the incoming data, your cluster will be automatically scaled to take care of all the incoming data. So that's what serverless means. And provisioned is like you have a very good understanding on how your business is going to be. You have a prediction, and you have uh, based on that you plan your capacity. And in addition to this, we also have a concept called concurrency scaling or auto scaling. So even though you have a provisioned your computing devices, in unforeseen situations where your capacity is not enough, based on your auto scaling setting, the new clusters will be automatically added. They'll be taken care by Redshift. So that would be the primary difference between serverless and provisioned clusters. And here, if you can see below in the diagram, you have something called Amazon S3. So Amazon S3 is primarily used, uh, or we have some concept called AWS Redshift Spectrum. So for that, S3 is used. So what happens is, um, there will be some data which is not usually used in the business for reporting purpose or analytic purpose for anything. So very frequent, maybe once in a year or once into a year, you may need to retrieve that data. And it is not wise to store the huge volumes of the data which is not required on a Redshift cluster, because it comes with some cost, right? So S3, when compared to Redshift, is a cost efficient option. So with large volumes of data, there are different categories in S3 also, different storage classes. So you can store it in the least storage class and access the data whenever you need it, maybe once in a year. So usually for the cases where the data needs to be accessed very few times, then is when you'll use Redshift Spectrum. And we have Redshift managed storage for RA3 node types and for serverless. Uh, Redshift uses this Redshift managed storage, and we also have data sharing clusters. Let's say we have different clusters. So every company in the real time, they don't have a single cluster or a 10 node cluster. So the volume of the data is very high, like in GBs or TBs. So everything can't be handled in a single cluster. So they will create multiple cluster with a 100 node configuration. And um, and not everyone, based on different use cases, not everyone would want to save the data in the same clusters. For that reason, uh, so very simple use cases, some data can be accessed by, or most specifically, if I have to say, HR related data. So employee information is a P2 information. So not everyone should have access to it. Only HR or the relevant people needs to have access to it. So that kind of information needs to be stored in different clusters, and the other business data needs to be different, stored in different clusters. So because of this, having different clusters across accounts or across um, within the same account, there could be different cluster. There will be use cases where you would want to have access to the data in a different cluster sometimes, and in those scenarios, we have this concept called data sharing. And we also have Amazon SageMaker here. I think we don't need to learn anything about this, because it only takes data from Redshift to do some machine learning, to run some machine learning models. So it will just interact or integrate with Redshift. But yeah, there's not much we need to learn about SageMaker, at least in this course. Yeah, before I move, any questions? Okay. I think we are already running out of time. Let me finish the agenda at a high level. So, and again, the Redshift performance features, massive parallel processing, columnar data storage, or data compression. These are also uh, form the basis of the architecture. So we need to understand what massive parallel processing is as a concept. You don't need to uh, it's not a something you need to it would be very difficult to learn. It's just a simple concept. And columnar data storage also, we need to understand how the traditional database stores the data and how AWS Redshift stores the data. So usually it's a row level storage, but Redshift is a columnar data storage. So in the upcoming session, we'll in detail understand what is massive parallel processing, what is columnar data storage, what is data compression, and how and how these will uh, help us in improving the cluster performance. And coming to the next one, which is best practice for designing tables. So, and again, and having an understanding on what a sort key is, what a distribution style is. So it is very important, and we will discuss them in detail. So basically, at the time of creating a table, we define what needs to be the sort key of that table, what needs to be the distribution key of that table. So these two aspects will help us in efficiently storing the data, utilizing all the nodes we have. And also when someone wants to retrieve the data access will be little faster. Uh, so we need to understand this concept and configure it at the time of designing the tables. Yeah, I have just given a little more description about what massive parallel processing is. But yeah, we'll skip this and move to the next agenda that we will be covering in the session.
So I have one question. This is
Yeah.
Santosh. Yeah, actually, I'm a SQL DB, a SQL server. So, do I need some Linux skills also to learn AWS Redshift or?
No, no. I think it's not required. It's not a prerequisite. And since you already
Mhm.
have some understanding on MySQL, I think learning Redshift will
No, no,
be fair.
SQL Server. No, no, Microsoft SQL Server.
Okay. Yeah, 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 yeah. No,
Okay,
we don't need to learn any programming. Everything we can take care from the console itself,
okay, okay.
creating cluster,
So you said
monitoring.
it's columnar database, right? So is
Yeah.
it still the DBMS database or is it NoSQL kind of
No, it's a RDBMS. It's a
RD?
relational database. Yeah.
Oh, so like who are the competitors for the Amazon Redshift, like equal competitor?
So currently, the market leaders in data warehousing, one is Redshift and another is Snowflake, and we have Google BigQuery, and we have one service from Teradata and one product from IBM. So these are the main players.
Okay, so Snowflake and I think Amazon Redshift both are like competitor,
Yeah,
right?
yeah, they are. Yeah, most of the companies use these two services.
Okay. So like will there be specifically AWS Redshift jobs or like will people ask with multiple, like how it will be like regarding jobs
Yeah,
search?
yeah. So I think it totally depends on the company. So whatever I have seen previously,
Mm-hmm.
um, so in certain companies there will be a database administrator or a DB engineer who solely takes care of Redshift. So it's the only job they need to do is maintaining the cluster, creating tables within Redshift, and in doing that maintenance of the cluster whenever it runs into some problems or some bottlenecks. And in companies, there are scenarios where Redshift needs to integrate with QuickSight, let's say, for reporting. So QuickSight needs to have the data from Redshift, and Redshift can also integrate with we can say we have something called MongoDB. It's also mainly used for production purpose.
Mm-hmm.
From Mongo or from Aurora, someone wants to establish a connection. So yeah. So, but mostly having a knowledge on Redshift alone will be enough for most of the cases, because if a company is using only Redshift and other tasks are taken care by some other employees, then they may not really need to know other services, except you need to have some understanding on things like IAM roles.
Uh-huh.
um, yeah, very other services. But yeah, at a high level, I think having Redshift, or I have personally, I have seen a lot of jobs mainly focusing on Redshift as a skill.
Okay, okay. So how
It
many
totally
hours course will it be?
So I think there are about 30 to 31 sessions, I guess, daily 1 hour. So yeah,
Hmm.
all these concepts or the topics will be covered in those 30 sessions.
Okay. And regarding certification, like what type of certifications are there for AWS Redshift?
Yeah, for AWS, we have different kind of certifications, but that's mainly is required for job roles like solutions architect or
Hmm.
things like that. Yeah, mostly for solutions architect, they
I
need to
heard
have a
this data analytics specialty or something
yeah,
that
yeah, yeah.
covers
It
Redshift.
will be covered under data specialty.
Analytics.
And recently, there is also a database specialty certification that was introduced. I think, yeah,
Um,
Redshift will be part of that also. But Redshift as an individual service, I don't think there is any certification, only for Redshift.
hmm. Okay. All right. Yeah. Thank you.
Okay, yeah, let's quickly move on to next. Yeah, we will be discussing workload management. Within workload management, we have different concepts of how to configure and how to auto scale based on the concurrency. What is the difference between manual workload management and automated management? And yeah, just like we have discussed, we'll also be checking in detail, or actually creating or looking at some examples on querying the data from Redshift, which is stored in S3 buckets. So that will be covered in this Redshift spectrum overview. Yeah, this is just a mm, view of workload management, and this is the visual of a Redshift spectrum on how it works. And other important aspect is understanding the system tables and views. So when you are designing tables, and when so in my last organization, there are always about 2000 queries running, a lot of people creating queries for some data, for their weekly business reports, or it could be monthly, or for any meetings, high level meeting, they need data. So there are about 2000 queries that are running parallelly across the day. So when such large amounts of users are querying your cluster, sometimes they may not be well written, or they not be efficient. Due to those scenarios, your cluster will be impacted. So for you to understand like what data is stored in what table, and what is the CPU utilization or the disk utilization in the cluster, and who are the different users, and what are basically to understand the table schema. So you need to have an understanding of system tables that we will be discussing. And to launch a cluster, or you need to have a overall understanding on how the pricing is, what are the difference of node types that are supported by Redshift. So we have DC2, which is dense compute and dense storage, and we also have RA3 cluster types or node types. So based on the use case, we need to select the right node type. We will discuss on that also, and we will discuss the difference between reserved node and on-demand node, and what the difference is, and in what scenarios we will use a on-demand node or a reserved node. We'll discuss that. And Redshift management overview. So we will have a console. So this is the view of the Redshift console. So here we have different options or the features, where one tab is used for query monitoring, or different understanding your how your current workload is in terms of your workload management settings. We'll understand that based on query monitoring and cluster performance as a cluster. So if you have a 10 node cluster or a 100 node cluster, how are the different nodes performing? How is your CPU utilization and disk space utilization? And there are a few more metrics which will help us under how cluster is performing. And maintenance, so like we have discussed like in one of the slides, so we need to have alarms or events for us to avoid any unforeseen incident. So CloudWatch is one of the services which captures this information and helps us with those alerts. And yeah, backup, we also have a option called backup where we will configure the taking snapshots for backups. Are we taking a full snapshot, or are we taking an incremental snapshot? What is and what is the schedule? Should it run on a daily basis, weekly basis? So everything will be configuring in the backup section. And properties is something which gives the overall configuration details of the Redshift cluster. So what are the IAM roles that are tagged to this cluster, and database configuration, network configurations, VPC details, security groups details, things like that. So we will understand everything from the cluster console itself. So for a DBA, it's very important to understand what each of these tab provides for us to have a healthy cluster which will not run into problems. And this is very much required in a real time when you're working on huge volumes of data with a lot of tables and nodes. So that is extremely important. Yeah, I think considering the time, we have discussed uh, the overall overview of Redshift and how the sessions are going to be and what all we will be learning in the session. Now, I have just given an overview, but in the daily sessions, we'll go into depth. We'll discuss each feature in detail and see how we can make use of them in the real time cases. Yeah, that's it from my side, guys. If you have any questions, please let me know.
How long it will take to complete this Redshift course?
Yeah, I think in about 30 to 35 sessions, I think we should be able to cover everything.
Okay,
And
basically
yeah,
1 month.
yeah, 1 month, yeah.
Okay.
And during these 30 days also, we can have both theoretical concepts and also practicals. So practicals are more important. They will actually help us understand how the console is, what all can we do from the console, loading the data, creating clusters, tables, things like that. That will be very helpful. Hands-on will be the best way to learn.
So you will have any kind of real-time scenarios like that will explain those things.
Sorry, I didn't get your question.
So do you cover the real-time scenarios? How the Redshift and everything in the real-time
Yeah, yeah.
session?
So basically, yeah, it may not be real time, but we will be doing everything. I think I can show you everything right from how to launch a cluster and how to load the data, how to manage it, and yeah, different real time use cases. But yeah, we may not be working with large volumes of data, but in real time scenario, basically that would be the steps we'll be taking whenever we have a requirement to create something, to move the data from one table to other, or from S3 to Redshift, or whenever, if you want to take some backup of the data, if you want to schedule a maintenance window for the cluster, all these things I think we will be doing, and the same steps will be followed in the real-time cluster maintenance also. Any other questions, team? From Naveen, Raja, Santosh?
No, I don't have any question.
Okay, yeah, I think thank you all for your time for joining this session. Hope this was helpful. But yeah, please learn as much as you can with respect to Redshift. I think this is one of the prominent data warehouses we have in the current market, and this will definitely help in moving to tech roles or in scaling up your current skill. That's definitely going to help. And yeah, thank you so much, everyone. Thanks for your time. Have a nice day.